Yellowstone National Park is famous for harsh winters, but a new study shows summers are also getting hotter, with August 2016 ranking as one of the hottest summers in the last 1,250 years. The new study drew upon samples of living and dead Engelmann spruce trees collected at high elevations in and around Yellowstone National Park. Engelmann spruce live between 600 and 800 years and rot relatively slowly. The pristine setting of Yellowstone National Park provided an opportunity to source samples from living and downed trees dating back 1,250 years. Previously, temperature records for the Yellowstone region were only available going back to 1905. The findings were published in Geophysical Research Letters. The Greater Yellowstone dataset is publicly available on the International Tree Ring Databank from NOAA. The climate data gleaned from the tree ring samples fits closely with the instrumental record over the past 100 years. The team was also able to identify several known periods of warming in the tree ring record, including the Medieval Climate Anomaly that occurred between 950 and 1250, as well as several multidecadal periods of cooling that occurred prior to 1500. The records show that the 1080s were extremely warm, and in the 16th century, there was a period of prolonged warmth for about 130 years. But the team, led by Karen Heeter, a dendrochronologist at the University of Idaho in Moscow, found that the 20th and 21st centuries, and especially the past 20 years, are the hottest in record. The warm periods of the past were characterized by substantial multidecadal temperature variability, markedly different from the prolonged, intense warming trends seen over the past 20 years. The new record provides crucial data for scientists seeking to better understand the relationships between increasing temperatures and environmental factors like fire regimes, seasonal snowpack, and vegetation changes, Heeter said. The warming trend we see beginning around 2000 is the most intense in the record. The rate of warmth over a relatively short period of time is alarming and has important implications for ecosystem health and function, exacerbating droughts, wildfires, and other types of ecosystem stress, she said. A hotter and drier climate could also affect the famous hot springs and geysers in Yellowstone. A geyser's eruption is fed by a complex, underground vent system filled with water. As Yellowstone's volcanic system in the underground heats up the groundwater, pressure will build up until it is sufficient to trigger a steam eruption on the surface. Controlling geyser activity is the rising or falling groundwater table, drought periods reflecting a decrease in geyser activity. A study published in 2020 shows a decrease in geyser long-term activity around 1233 to 1362 CE, coinciding with a warmer climate, also shown in the new tree ring record, and a pronounced megadrought in the 13th and 14th centuries across the region.